If you are one of those who think that diodes are very simple, I must say that you are completely wrong. It is really unfair to think that diodes are very simple components and they can only rectify current. In this video, I will talk about diodes and their application, not inner structure or chemistry, and introduce 3 main types of diodes with 8 applications of them in circuits. Please stay with me in the rest of this video. Diodes, these little components, are so tricky. They put out of sight their talent. Maybe they are afraid of being used in your project. But don't worry, I will reveal their secret in few minutes. To begin with, I'm gonna take a brief look at ideal diode. This is a schematic symbol of a diode. It has 2 pins, anode or positive and cathode or negative. There is a line in cathode side of real diodes to specify a negative or cathode side. Look here, this silver line here, and this one. And this diode specifies cathode side by a black line. If you change this line to a shape like S, first letter of Schottky, it becomes a Schottky diode schematic symbol like this. And if you replace this line with a shape like Z, first letter of Zener, it becomes a Zener diode schematic symbol. And if you surround the diode symbol with a circle, it becomes an LED symbol. This component will allow current to flow in this direction from its anode to its cathode, and it will block current in opposite direction. If you put voltage to diode in right order, I mean positive voltage to anode pin and negative voltage to cathode pin, then your diode is in forward bias setup and will allow current to flow. But if you put voltage in opposite direction, then your diode is in reverse bias setup and will block current from flowing. First application of diodes came from this definition. Application number 1, using diode as rectifier. Diodes can pass electricity only in one direction. If you put a diode in an alternative current path, it will allow electricity in one direction and block opposite direction. Look here, this is a half-wave rectifier. It just passes positive half of sinusoidal wave and block negative part. Look at this diode carefully. If you apply this yellow signal on anode pin of this diode, you will get this blue signal on cathode pin. This is a full wave rectifier. I am gonna test it. And this is a full wave rectifier which pass either negative or positive part of waveform to output, and in the same time convert negative wave to positive. A full wave rectifier works like this. This yellow signal is input sinusoidal wave and the blue one is output of rectifier. You see negative part is reflected to positive side by rectifier. It seems easy, but you have to be careful in selecting proper diode. These are 3 important parameters to consider in selecting diode. All of these parameters are available in datasheet. In datasheet of every diode, it is available to check how much voltage the diode will tolerate in reverse bias setup. For example, if you are going to rectify AC power in United States by half-wave rectifier, you can use these, but you can't use these because of shortage of reverse blocking voltage. Contrary to what most newbies think, application of diodes is not limited to rectification. Second application of diodes is my favorite. Application number 2, Using diode for reverse polarity protection to protect our product from inverted polarity. Think about your product. The result of all those efforts can be lost with just a small mistake. If the user connect power supply in wrong polarity, main parts of your circuit will blow up. Microcontrollers, regulators, ICs, and other stuff. But you can prevent the disaster with a tiny and cheap Schottky diode. Why Schottky diodes? How to do that? I will explain. This circuit here presents your main design, and here is power input. You must connect your power supply in right polarity, I mean positive side here and negative side here. Connecting wrong polarity, even for a very short period of time, will blow up whole project. But if you use a Schottky diode here in this way, it will protect entire project from reverse polarity. You may ask why Schottky diode is used here. Because Schottky diode drop very low portion of input voltage, for example 0.2 volts. If you use an ordinary diode here, it will drop around 0.7 volts of power supply. But Schottky diodes drops only 0.2 volts. Sometimes you need to use a rechargeable backup battery in your project to ensure the device works when power is down. There are many solutions, but using a diode is one of the most simple and cheap approaches. Third application of diodes in circuits is to connect battery and power supply together. Application number 3, using diodes to connect multiple power sources. Here is most simple way to connect backup battery to power source. Look here, ground of battery and ground of main power source are connected together here. There is a diode here which connects 12 volt of battery to 12 volt of main power source. When power source is up, voltage difference on anode and cathode of this diode is about 0 or even negative voltage, and diode is off, and the device will work with external power source. But when external power source is down, battery power will flow through the diode and keep the circuit working. I believe you are thinking about charging this battery. Yes, this is a real concern. We need a battery charging circuit here to charge the battery when the external power is up. I will explain how to do it in one of my next videos. You saw diodes can pass electricity in one direction. This is very first definition all of us learned diodes with. But I recommend to change this definition to a voltage-oriented definition to better understand some parameters. Voltage-based definition is this. Diodes can conduct voltage from their anode pin to their cathode. I mean, if you apply DC voltage to anode pin of a diode, it will conduct voltage to cathode pin. But if you apply voltage to cathode pin, anode pin of diode will not affect it. Be careful, it is serious danger to grab a diode from cathode and plug the anode pin to outlet. As said, diodes cannot conduct voltage from cathode to anode, but I mean DC voltage in circuit, not AC power line and your body. In an ideal diode, the voltage come intact from anode to cathode. But in a real diode, a portion of voltage stays on diode and remaining voltage pass it and goes to cathode. This feature brings us fourth application of diodes. Application number 4, using diodes to reduce voltage. Assume that you need 4.3 volts somewhere in your project, but main voltage in your circuit is 5 volts. For example, you need to run DF player module to play music or sound effects in your project. Since this module works with 4.3 volts, you have to provide this voltage for that. What you can do? First thing I think about is using an adjustable voltage regulator and set it on 4.3 volts. Actually, this is best method to do such a project, but using regulators increase project cost. In some cases, you can use drop voltage of a diode to reduce voltage. You may ask how much voltage a diode can drop. It depends on diode type, ambient temperature, and current flowing through diode. But impact of ambient temperature and current is ignorable in many cases. Because of that, we consider diode type only. Diodes usually are made of silicon or germanium. Silicon diodes drop voltage around 0.7 volt and germanium or Schottky diodes drop lower, around 0.2 volts. Exact drop voltage is available on datasheet of each part number. For example, look at this datasheet. Drop voltage of 1N5822 diode in room temperature and current equal to 3 ampere is 0.52 volt. And look at this one. Drop voltage of 1N4007 diode in room temperature and current equal to 1 ampere is 1 volt. And our last example, 1N4148 diode. Let's look better at this diode and its forward voltage. This is forward voltage graph from datasheet of 1N4148 diode. In first sight, it is clear that the forward voltage is a function of temperature and current flowing through diode. Let's consider this point. Here the temperature is 30 degrees and current is equal to 10 milliamperes. In this point, forward voltage is around 0.7 volts. By increasing current, forward voltage will get bigger. This approach for reducing voltage is not best way, but it has its own advantages. It is super simple and cheap, and you can use a bunch of diodes in series to reduce more and more voltage. But you have to be careful. If you use many diodes in series to reduce more voltage, impact of current on voltage drop will be impressive. Let's go to fifth application of diodes. Application number 5, using diodes as flyback. With a little experiment in electronics, you may have seen a diode attached to every relay in circuits. This diode is called by many names: flyback, flywheel, snubber, suppressor, clamp, and some other names. Some of newbies don't use this diode in their design because they think it is useless. But this is one of the most important things to do in your circuit design. By placing a diode in parallel with relay or other inductive loads, spikes produced by them will be eliminated. By removing this diode from your design, be ready for awful things in your project. Look here, one flywheel diode stands beside each relay and connected to it in parallel. Cathode pin of diode is toward VCC. In this circuit, I am using a tactile switch to connect or disconnect the diode to see its impact. I am gonna use my function generator to turn the relay on or off 5 times per second and use my oscilloscope to see what is happening in collector pin of transistor here. Look at this spike here. It's about 10 volts. When you press the tactile switch, the diode will enter the circuit and eliminate the spike. This is magic of diodes. Look here. The spike is gone. This is the magic of diode. If you refuse to use this diode here, the microcontroller in your circuit will reset every time the relay switches off. It is not just relays. All types of inductive loads make spikes, like DC motors, buzzers, solenoids, and etc. And it is strongly recommended to use a flywheel diode beside them. Till now, we just considered ordinary diodes. It is time to introduce Zener diodes. Zener diodes are same as ordinary diodes in forward bias, but they act different in reverse bias. Zener diodes have a precise reverse voltage, and this characteristic brings us next application of diodes. Application number 6, using Zener diodes for regulating voltage. Let's consider 18 volt Zener diode. It means in reverse bias setup, it will block current by voltages under 18 volt and start to pass current by voltages over than 18 volt. and it will do its best to keep voltage on itself at 18 volts. Notice that we are talking about ideal Zener diode. Look here, this is simple Zener diode circuit. Zener diodes are generally used with a resistor in series to limit current and protect Zener diode from blowing up and to make reference voltage here at this point. But this resistor limits reference voltage power either. I mean, this point cannot provide so much current. So we need to amplify current on this point. There are so many ways to do that, but one of most easy and handy way is to use a BJT transistor, which is explained in this card. And another way is to use an op-amp. I will explain this one in one of my next videos. Application of Zener diodes is not limited to making reference voltages. They sometimes used for protecting circuit from overvoltage. Let's see it. Application number 7. Using a Zener diode to protect circuit from overvoltage. There are so many ways to protect circuit from overvoltage, but one of the most simple example of them is to use a single Zener diode. You may wonder how it is possible. Let's see example. This is a sample circuit. You can use a Zener diode here with a fuse like this. If voltage in power supply remain in right value, for example 12 volts, Zener diode in reverse bias will remain off. But if overvoltage happen here in power supply, Zener diode will pass lots of current to keep voltage here on 12 volt, and this current will burn the fuse and save whole project. A single Zener diode in cooperation with a fuse can save whole project. This is amazing. So let's go to next type of diodes, light emitting diodes or LEDs. Don't look at LEDs like simple or trite components. They are used for many purposes. Lighting up, showing device status, showing parameters, helping plants to grow, or even communication. These are most important application of LEDs, but I'm gonna talk about my favorite. Application number 8, using LEDs for remote communication. LEDs are used for emitting lights, even invisible lights, like infrared or ultraviolet. Most of remote controllers these days are using infrared pulses to communicate with devices. Let's see how they work. This is a simple remote controller. If I press any button, it will make infrared pulses here with this IR LED. Look here. If you look at your TV remote controller, you cannot see anything, but here pulses are visible because these pulses are visible to camera, even your cell phone camera. We saw pulses, but how they work, how we can use a remote controller in our project. There are IR remote receiver components out in market in various shapes, types, and part numbers. But one of the most popular one is this, with 3 pins. 2 of them are for powering up the component, and third one is for data output. This is sample circuit of 3-pin infrared receiver. If I press any button on remote controller, pulses come into LED and we can see it. In one of my next videos, I will fully explain IR remote controllers and receivers and will make a simple project with them to demonstrate how exactly they work. So that's it. We considered 3 main types of diodes with 8 applications of them. Even though there are other types of diodes with other applications, I think it's enough for now. I hope you enjoyed. Thanks for watching. If you like this video, make sure to subscribe for more. Here, hit this button.